my name is Bobby Boyles, and I've been working on this project, which is titled The Comparison of Cretaceous Paleogene Boundary Sediments from South Carolina and North Dakota. And I've been working on this with Dr. Adam Smith over at the Geology Museum. Um, so, as sort of an introduction, an asteroid hit the Earth 65 million years ago, and it left a geologic indicator in the form of the KPG boundary. So what we see with this boundary is the asteroid just kicked up a lot of dirt and dust, and it got deposited in the form of like this this line of ash, basically, and dust and stuff in the record. And what we look for in that is shocked quartz and microspherules. So shocked quartz is a quartz that's only formed under quartz when quartz has been under a very high temperature and pressure for a short amount of time, like a shock, and that manifests itself in the form of these lineations that you see. And we also see microspherules. So what happens with the microspherules is when all this dust and ash and stuff and rock is kicked up into the atmosphere, it's very hot and it's basically liquid. And when it starts falling back down to Earth, it starts to cool and it's spinning. So it cools in the form of this like little sphere. So that's what microspherules are. So what we did with this project was we looked at boundary sediments from both South Carolina and North Dakota, and just to kind of look for both shocked quartz and microspherules in each of those localities. So that's what we did. So for the methods, the first thing I had to do was collect a sample of the boundary from South Carolina, and I did this at a sand mine near Columbia with the help of Dr. Scott Harris. So he helped me a lot with that. And so the North Dakota sample had already been obtained by the Geology Museum. Went on a field trip to North Dakota a few years ago to look for fossils and stuff like that. So they got this sample of the boundary while they were there. So the second part after we got the samples was to cut them down to billets so that they could fit on a microscope slide. And on the right here is the rock saw that I used to do that. And so after we cut them down to billets and affixed them to their slides, we started grinding them down so that we could look through them, so they have to be really thin. We didn't get to finish that because of all the COVID restrictions and stuff like that, so we had to send them off to a company for completion, and we just got those back recently, and I've been looking at them under a microscope. So yeah. So after we got the slides back from the company, I started looking at them under the microscope, which you can see here on the right is the microscope of the camera in the mineralogy lab. I'm sure you're all familiar with that one. So I've been looking at them under various magnifications. You can see on the right, you can see on the screen on the TV, that's just a piece of quartz that I was looking at. That one's not shocked, I don't think, but it's kind of cool. So one of the big things I've been looking for is extinction, to kind of separate the big grains of quartz and stuff from all the little clay particles and stuff like that it's like a clay matrix. It's a clay matrix, and it sort of is kind of surrounding everything else. So I've just been kind of using the extinction to look for points of interest. So obviously I've been doing that under cross-polarized light, and I've also been taking pictures under normal light to kind of see the difference. So yeah, that's what I've got so far.